All right, CJ Math students, I've now welcomed you to part 2 of notes 8.1. So again, we're here on the my turn problem. We'll call this 1, call this 2, 3, 4, 5, and 6. All right, so to the nearest tenth of a foot, let's underline that because that's going to be important. We're always not going to get straight whole numbers. Sometimes we're going to have to round. Find the length of the diagonal of a rectangle with a width of 4 and a length of 10. So I've messed up here that says 6 and 8, so we should go ahead and change that to 4 and 10. And now, what do we know about rectangles? We know that they're comprised of a whole bunch of right angles, 4 of them in fact, and a diagonal should be code for, it's the length opposite the right angle. So knowing that it's opposite of a right angle, we know that, hey, this diagonal is a hypotenuse. And usually you can go ahead and write that down. Diagonals usually are hypotenuse. So again, you're going to be using this a squared plus b squared is equal to c squared. And again, x is the thing that we don't know, so we can say x squared. Right? So 4 squared plus 10 squared is equal to x squared. 16 plus 100 is equal to x squared. And then 116 is equal to x squared. Now, if you're looking at your square root chart, you're like saying, well, I don't see 116. Yeah, so again, we're going to go ahead and round this. So we'll say the square root of 116, and we'll get x is equal to it's like 10.77032 blah yeah. Well, they want us to round this to the nearest tenth of a foot, so that's 10.8 feet. Right? So given this right triangle that has sides of 4 and 10, the diagonal must be 10.8 feet in order for it to be a right triangle. Right? Now, this is a very different problem. Notice how I have a measure on my hypotenuse. Every other time we've done this, I have not had a measure on my hypotenuse. I've had a missing or an x, right? When you have the measure of the hypotenuse, you can change this a squared plus b squared equals c squared into something that can solve for b, right? So if I wanted to solve for b, I could do a little algebra here, and I could say, all right, let's subtract b squared from both sides, right? If I do that, I get a squared is equal to c squared minus b squared. And I can say, all right, let's subtract c squared from both sides. I get a squared minus c squared is equal to negative b squared, and then I divide everything by -1. And in doing so, I get this new formula that's like something that looks like c squared minus a squared is equal to b squared, right? All that does is tell us, hey, when I have the measure of my hypotenuse, I can use a variation of a squared plus b squared equals c squared. I can use this c squared minus a squared equals b squared, and I can solve for my hypotenuse. So again, if I have the measure of the hypotenuse, I want to use c squared minus a squared equals b squared. If I don't have it, I want to use a squared plus b squared equals c squared. So here I do have it. So this is an example where I want to use c squared minus a squared equals b squared. C squared, as c always stands for my hypotenuse. A and b you can switch up, doesn't matter, right? But c squared always stands for my hypotenuse, so I'll say 5 squared minus the other thing that I do know, which is in this case 4, the other leg that I do know is equal to b squared. 5 squared is 25, minus 4 squared is 16 is equal to b squared. 25 minus 16 is 9 is equal to b squared. And just like we did in the last one, we take the square root. So the square root of 9 is that b is equal to 3. So a right triangle with a side of 4 and a hypotenuse of 3 has another side of 3. Even though that looks way longer than 3 because these sides are shorter, or this 4 is shorter in geometry, you can, unless it says or drawn to scale or something like that, like always just assume that if you've mathematically proven your answer, don't worry about how it looks. That's the right answer. All right, so question 5. The area of a square is 36, right? Find the length of each side, then find the length of the diagonal to the nearest tenth. So first of all, they want us to divide a diagonal here, and they want to say, all right, find x, right? So first of all, we can use our area formula for a square to find out the sides, right? So if the area is 36, you can plug in 36 is equal to s squared, right? And then how do I solve this? Just like if I had something like 9 is equal to b squared, how do I solve this for s squared? I take the square root. So to undo something squared, I take the square root. So s is equal to 6. So that means that the sides are 6. So now you can envision you have a right triangle, because we always have a right angle in rectangles and squares, with sides of 6, and they're saying find the hypotenuse. So what type of formula will we use here? Well, if I don't have my hypotenuse, that's a squared plus b squared equals c squared, right? So 6 squared plus 6 squared is equal to c squared. 36 plus 36 is equal to c squared. And 36 and 36 is 72. So 72 is equal to c squared, so we just take the square root. And the square root of 72 is going to give you a decimal. So no need to worry about getting decimals. And the problem said, find the length of diagonal to the nearest tenth. So you take 72, you square it, and you get about c, I'm sorry, I'm going to put it over here, c is equal to about 8.485 to the nearest tenth, right? So that would be c is equal to 8.5. That's it for part 2.